This is practice A for section 7.2. We're going to tell whether the triangle is a right triangle. So they give you three side lengths. 15, 20, 25. Those numbers probably should look familiar to you at this point. Those are a triple. 3, 4, 5 times 5 gives you 15, 20, 25. So that automatically means this is a right triangle. So yes, this is a right triangle. 8, 15, 17. That's a triple. It's a right triangle. Now, the math that's involved in that, if you aren't aware of your triples, you should be at this point. But 8 squared plus 15 squared gives you 289. And notice how 17 squared is the same thing. That's how you know it's a right triangle. Next one, 16, 21, 24. Those don't strike me as numbers that I'm super familiar with. So I'm going to put this in the converse of the Pythagorean theorem, which is what we just did here. 16 squared plus 21 squared. If it's a right triangle, those are the legs. That gives you 697. And on the other side, we have 24 squared. That's 576. These are not the same. This is not a right triangle because the leg squared and summed is bigger than hypotenuse squared. We talked about this before, but this is an acute triangle. And that's what they ask you to do in this bottom section. Determine whether numbers can represent the lengths of the sides of the triangle. That's step one. Step two is, if they do make a triangle, classify the triangle, acute, right, or obtuse. So you know what right triangles look like. You know what acute triangles look like. Obviously, obtuse triangles would be if this number is bigger than this number. Okay, so first thing you have to do is you have to make sure that the figure is a triangle. 6, 8, 10, again, that's this triple 3, 4, 5 times 2. This is a right triangle. I know that. I know my triples. I don't need to do any work. Now, an example like number 5, 5, 7, 9, those aren't a triple, but that doesn't mean it's a triangle. Your two smallest sides together, when you add them, better be bigger than the biggest. 5 plus 7 is 12. 12 is bigger than 9. So this is a triangle. That's what you do first. Now, the second thing you do is you square 5 and you square 7, and you compare it with 9 squared. So I'm going to type that into my calculator, 5 squared plus 7 squared. That gives me 74. I know that 9 squared is 81. 81 is bigger than 74. Notice how that's different than what we had going here. This is obtuse. Number 6, 8, 9, 10. Make sure it's a triangle first. Two smallest sides, 8 plus 9, that's bigger than 10. This is definitely a triangle. Now, check. What is 8 squared plus 9 squared? Compare that with 10 squared. 145 is bigger than 100. This is an acute triangle. Okay, so those are the only options that you're going to have. It's either right, acute, or obtuse. You've seen an example of both. Okay, now I'll do number 7 also, because this is a special type of one. Don't automatically just throw these numbers into the converse of the Pythagorean theorem. You need to make sure this is a triangle. These are your two smallest sides. If you add them, are they bigger than the biggest? And they're not. So I'm just going to write this down, that 10 plus 12 is not bigger than 30. This is not a triangle. I'm not saying it's not a right triangle. I'm saying you cannot make a triangle with these lengths. You need to check that first.